Okay, let's look at question 8 from November 2018. It says, corrosion is a redox reaction that takes place in the presence of oxygen and water. Rusting is the corrosion of iron leading to the formation of iron 3 ions. Now look here. This is very important, this 3 in here. It tells you that we are going to get Fe 3 plus ions, because remember, iron can be Fe2 plus or Fe3 plus, but in all of this we need to know we've got Fe3 plus ions. It says define oxidation in terms of electron transfer. Remember, oil rig, red cat. Oxidation is loss of electrons. Okay. Alright, then it says to you, a cleaned copper rod and a cleaned iron nail are placed in a beaker containing water at 25 degrees as shown below. After a while it was observed that the iron nail was coated with rust. The copper rod showed no visible signs of corrosion. 8.1.2, write down the half reaction for the iron nail. So iron is being oxidized from iron metal to iron ions, and remember they are 3 plus ions because it says so in the question. It makes you iron 3, and so this reaction will be iron going to Fe3 plus plus 3 ions. If you're not confident writing it by yourself, remember you can go to the table of electrode potentials and look for this half reaction. Now it says to you, does the iron act as a reducing agent or an oxidizing agent in the beaker? Well, the iron is losing electrons, so it is being oxidized. So if it is being oxidized, it has to be a reducing agent, because remember this topic is full of confusing terminology. So if you are oxidized, you are a reducing agent. Okay, now it says to explain the above observation by referring to the table of standard reduction potentials. So if we have a look at this table, okay, this reaction is the one possible reaction, and the other possible reaction is the copper reaction. Okay, copper goes to copper ions plus 2 electrons, and it's always copper goes to copper ions. If we go have a look at this table and we have a look here, where is copper? Copper to copper 2 plus, it is over here. Okay, and the iron 3 plus to iron is over here, and it says this is increasing reducing ability for the forward reaction. Copper 2 plus plus 2 ions goes to copper, increasing reducing ability. So if you can reduce, you are an oxidizing agent. But then if we go down here, we want to be a reducing agent. We are actually looking for a reducing agent because iron is the reducing agent. So if we have a look in the table, okay, this one is lower down. It had the electrode potential of minus 0,6, and this one had a positive electrode potential of something like plus 0,52. Let's go back and have a quick look. It's 0,34. Where did I get that 0,52 from? 0,34. Okay, so this copper one is 0,34. Okay, so in terms of reducing ability, however, iron, what question number are we? 8.1.4. Iron is a stronger reducing agent. And remember, it's iron metal, not the iron iron. Iron is a stronger reducing agent than copper. Okay, so iron is oxidized to the iron 3 plus iron. Okay. Now it says to prevent rusting of an underground iron pipe, the pipe is connected to a metal Q that corrodes easily. So here's my iron pipe, and here is the other metal. Okay, we do this in water pumps as well to stop pipes rusting. It says you are given two metals, zinc and copper, to use as a metal Q. So basically this is rusting, yes. This is rusting in this beaker that's going on here, and you're trying to stop this rusting. You've just proved here that if you put iron with copper, the iron's going to rust. So if you put copper here, the iron is going to rust. So it makes more sense to put zinc here. But we need to check from the table of standard reduction potential. So if you look over here, where here is copper, where is zinc? Okay, here is zinc over here. And now zinc is below the iron with a cell potential here of minus 0.76. But remember, if you go down the table, the pattern follows. So iron was a stronger reducing agent than copper, which means zinc is a stronger reducing agent than iron. Okay, so let's go back and say that. Okay, zinc is a stronger reducing agent than iron, and then you can say that the what do you call that thing, the electrode potential is minus 0.76. Okay, so zinc is a stronger reducing agent than iron, and so will be reduced to Zn2 plus instead of the iron. The copper would just sit there in the soil and let the iron rust. It says now a galvanic cell is constructed using the iron 3 plus, iron to iron 3 plus half cell, and a copper to copper 2 plus half cell. Write down the overall net cell reaction that takes place when the cell is functioning. Well, if you look up here where I wrote them down earlier, you can see that this one is got 3 electrons, this one's got 2 electrons. So 3 and 2, they are not equal. So what we're going to want to do is we're going to want to multiply the iron reaction by 2 and the copper reaction by 3 so that everything is balanced. So if we were to look at the charges on this, remember the iron is going to go to ions, okay, and the copper 2 plus ions are going to go to copper metal, and that would be my balanced reaction. So here's my half reaction iron to iron 3 plus, here's my half reaction copper 2 plus to copper, okay, but you have to remember that this is neutral, and then on this side I've got 6 positive charges, okay, from the copper on this side, and now on this side I've got 6 positive charges from the ions, so we have a balanced equation. Now it says calculate the cell potential of the cell. So remember, we write EO cell, and we go and we make sure, remember these formulas on the data sheet over here. You must write these formulas from the data sheet here exactly perfectly. Okay, so we're going to go EO cell equals EO reduction minus EO oxidation. And remember, you must write out the full word reduction and the full word oxidation, okay, because otherwise they're going to take your marks off. The formula must appear exactly as it appears in the formula sheet. So remember, the iron is oxidized, the copper is reduced, so the copper is 0.34, and then we are going to subtract the iron reaction, which was minus 0.06. Okay, so this is going to give me 0.40 volts, and that is the cell potential of the cell under standard conditions.